Hi everyone, I am Dr. Shahbaz S here. So in today's video, I am going to perform crosstab analysis in SPSS. Before going to video, please subscribe my channel and press the bell icon so to receive the more recent videos on statistical analysis. So today I will show you how to build a crosstab, understand counts, row percentage and column percentage, test the relationship using Pearson Chi-Square, check expected counts, interpret effect size using pi and Cramer V rule, and report the result academically. So we have a data set of 240 consumers about their purchased CN. So first of all, we need to see whether the data are correctly coded or not. So we will come to the values and see that 1 equal to male, 2 equal to female. And on the other hand, we see that 0 as per the consumer have no purchased CN. On the other hand, yes with purchased CN. Then click on OK. So we come back to data view. So before going to do crosstab in SPSS, we need to learn what is crosstab and what are the assumptions to perform this test. Okay, first of all, we need to come to PPT and we can see what is crosstab analysis. Cross-tabulation or a contingency table summarizes the giant distribution of two categorical variables. So each cell represents a particular combination of categories. Counts show how many respondents fall into each combination or category. Row and column percentage reveal patterns that raw counts alone may hide. Crosstabs are widely used before testing categorical association with Pearson Chi-Square value. So, according to our study, as we have data set of 240 consumer about their purchased CN and they are male and female respondents. So, we have a research question. Is gender associated with purchased CN or not? So, we set null hypothesis as gender and purchased CN are independent, and we set alternative hypothesis gender and purchased CN are associated. So we set significance level as 5%, means 0.05. So we check the assumptions by clicking on analyze button and go to descriptive statistics. Now we will perform the analysis in SPSS. We go back to SPSS file and click on analyze and descriptive statistics and then on crosstabs. We will put this categorical variable in row and purchased CN in column. Then we will click on statistics, click on chi-square. We also need correlation and then we need pi and Cramer V and click on continue. Cell, we need observed counts, expected counts, we need row percentage, column percentage and total percentage. Then click on continue. So we have no concern with formatting, we have no concern with bootstrap. Now click on OK. So we get the results. So you can see there are male and female and total percentage. You can see that there are 77.4% male with yes CN2 byproducts and 22.6% male have no CN2 byproducts. On the other hand, female 73.1% yes CN2 bygoods and 26.9% with no CN2 byproducts. So it means the decision of male is higher than the decision of female. So on the other hand, we can see the chi-square test. We have Pearson chi-square value is 0.563, which is not significant because the value of significant P is 0.453, which is greater than the value of significance level we set as 0.05. So it means there is no association. So we come back to our presentation. So we can see, first of all, assumption check. SPSS result 0 cell have expected count less than 5. Minimum expected count 26.50. So you can see in SPSS output, you can see 0 cell have expected count less than 5 and minimum expected count is 26.50. So in this case, we can interpret that the expected frequency condition is comfortably satisfied for Pearson Chi-Square test. Okay, so Now we come to Chi-Square test. Pearson Chi-Square value is 0.563, as you can see in SPSS output. 0.563, which is not significant. I mean the value is 0.45, which is greater than 0.05. You can see here Pearson value, and asymptotic value is 0.453. So you can see the asymptotic value is 0.453, which is not significant because we set the significance level is 0.05. So this value is higher than the significance level. So it means there is no statistical significant difference. Okay, we come to other CN. So we see the p-value is 0.453 is greater than the selected significance level is 0.05. So therefore we don't reject the null hypothesis. So it means what was our null hypothesis? Null hypothesis state that gender and purchased CN are independent. So it means both gender and purchased CN are independent and there is no association between gender and purchased CN. So we come back to here. So it means the sample doesn't provide sufficient statistical evidence of an association between gender and purchased CN. So on the other hand, continuity correction test value is 0.360, which is also not significant because the value of p is 0.548 is higher than the value of significance level 0.05. And Fisher test, you can see, is also not significant because the p value is 0.275 is higher than the value of significance level 0.05. And you can also see linear by linear association is value is also not significant. So if we go to SPSS results, you can find p value here. Pearson Chi-Square value not significant. Continuity correction value is this one not significant. Likelihood ratio not significant. Fisher exact test value is here, and but the p value is not significant. Linear by linear association value is 0.561, which is also not significant. So in this way we can simply infer the results that there is no association between gender and purchase. So on the other hand, we can see pi value is minus 0.048, but the p value is again higher than 0.05. You can find the pi and Cramer values here. Symmetric measures, you can find the pi values minus 0.048 and the Cramer v value is 0.048, and both value is higher than the significance level 0.05 because these value are p value. So in both cases the value of p is higher than the value of significance level 0.05. So it means we accept the null hypothesis and reject the alternative hypothesis because there is no association between gender and purchase decision. So thank you very much for this video and wait for my next video on statistical and quantitative tools.